Good morning to everyone. Today I am going to explain the structure of relational database. This topic comes under the database fundamentals and focus on how the data is logically organized using the relational model, which is the foundation of modern database like SQL, Oracle, and MySQL. The relational model is the conceptual framework proposed by E.F. Code. It explains how the data is stored in the form of relation which are nothing but tables. Data is stored in the tables. Tables are mathematically based on the relations. This model ensures data consistency, integrity, and simplicity. Because of these advantages, the relational model is widely used in real-world database applications. Tables. In the relational model, data is stored in table, also called relation. Each table represents the real-world entity such as student, employee, or product. Each table has a unique name represent one entity. Example, student table store and student related data. Row, I mean tuples. Each row in the table is called tuple. A tuple represents one complete record of the entity. Example, one record equal to one row. Each row contains values of all attributes. So, the tuples store actual data about the individual entities. Columns, I mean attributes. Columns are called attributes. Attributes describe the properties or characteristics of entity. Example, roll number identify the student, name, age. Attributes define the what type of information we store about on the entity. A complete relational database. A relational database does not consist of single table. It contains multiple tables that are interconnected using keys. Foreign key relationship reduce the redundancy, improve the data consistency. The practical example of student relations. Let understand the relational model using the practical exam. Here, the student table represents the students in a college. Real world mapping to the table. Each student has one row. Each property has one column. The student table contains 5 attributes: roll number, name, address, phone, and age. Each attribute has specific meaning. The data type is defined for each attribute. This structure is called schema of relation. Data organization. Each row stores the complete information about one student. Each column maintains the consistency across all the records. Each column contains only age value. Phone column contains phone numbers. The key concept. First one, attributes. An attribute is a column in a table. It represents a property of an entity. Example, name, age, address. Attribute define a structure of data. Next, the relation schema. A relation schema is the blueprint of the table. It specifies the table name and its attributes. Example, student, of roll number, comma name, comma address, comma phone, comma age. If the database consists multiple schemas, it's called relational schema. Tuple. A tuple is a single row in a table. It contains a complete set of attribute value. For example, 1, Ram, Delhi, 94551234 and 18. It is one example of one tuple. Tuple represent the actual data stored in the database. Relation instance. A relation instance is the set of all tuples at a particular time. Changes when the data is inserted, deleted, or updated. Next, degree. Degree refers to the number of attributes in a relation. Example, student name has 5 attributes. Degree equal to 5. Cardinality. Cardinality refers to the number of tuples or rows in a relation. Example, if 4 student record exist, the cardinality is 4. The column represent all the values of single attribute across all the tuples. Roll number column contain roll numbers of all students. Null values. Null represent missing, unknown or inapplicable data. Example, phone number not available for the student. Null is not 0 and not only empty space. Complete relational structure. This diagram summarizes the complete relational structure. Schema, the structure, attribute, column name, tuples, rows, values, actual data. Conclude, understanding this structure is essential of database design, querying and research. Thank you, students.